Hi everyone, welcome back to part 2 of Consumer Arithmetic. Let's get right into it. Let's move on to the second type of interest rate, that is compound interest. If the interest is added to the principal at given intervals, then it is said to be compound interest over a period of time. Now remember we said that in simple interest, both the principal and the interest remains constant every year. But that's not the same for compound interest. The sum of money earned or paid at the end of the transaction is called the amount. So for a rate of R% per annum over a period of n years, the amount is calculated by the following formula. Amount is equal to principal times 1 plus R over 100 to the power of n. And the difference between the amount and the principal is called compound interest, and this is seen below. Compound interest is equal to amount minus principal. When calculating compound interest, two methods can be used. There's a longer one which is seen in this example and a shorter one which uses the formula. Let's look at this example. Calculate the compound interest earned on the sum of $1,000 at a rate of 10% per annum over a period of 3 years. So for the first year, interest would be principal by rate by time, which is 1 year. So 10% of 1,000, which is 100. So the amount at the end of the first year would be principal plus interest, which is equal to $1,100, which now represents the principal for the second year. So interest would be 10% of 1,100, which is 110, and the amount at the end of the second year would be $1,210. For the third year, interest would be 10% of 1,210, which is equal to 121, so the amount would be $1,331. Hence, the total compound interest would be amount minus principal, which is equal to $331. Now, another way of calculating the compound interest would be the sum of the interest for each year. So 100 plus 110 plus 121 would give the same $331. As you can see, this method was long and can be time-consuming, especially if we had to work with fractions or if the period was longer. So the formula would be better to use since it saves time. So let's see how it works. In example 2, calculate the compound interest on $6,000 if invested for 3 years at 7.5% per annum. Using the formula, amount is equal to principal times 1 plus R over 100 to the power of n. Substituting values, we would get 6,000 multiplied by 1 plus 7.5 over 100 all to the power of 3, which would give us the amount $7,453.78. Now that we have calculated the amount, we can calculate the compound interest by subtracting the principal from the amount. So $7,453.78 minus 6,000, and this would give us $1,453.78. Now, as you can see, the formula makes it very easy to calculate compound interest. It was shorter, less time consuming, which is what we want, especially in exams. This brings us to appreciation and depreciation. And these are simply two big words for an increase in monetary value of an item or a decrease. Let's look at some examples. Jack bought a new car for $120,000. Its value depreciates at a rate of 10% per annum. Calculate the value of the car after 1 year and after 2 years. In part 1, before we can find the value of the car after 1 year, we must first find the depreciation, or the amount the car has decreased by. And to find this, it would be 10% of $120,000, which would give us $12,000, and so the value after 1 year would be $120,000 minus $12,000, which would give us $108,000. Part 2. So the depreciation after 2 years would be 10% of $108,000, which is the value of the car after 1 year, which is equal to $10,800. Therefore, the value of the car after 2 years would be $108,000 minus $10,800, which is equal to $97,200. In the second example, a vacation home was bought in 2018 for $90,000. If it increases in value by 5% each year, what is the value of the home presently? So this question is basically asking, what is the value of the home after 2 years? The increase in value or appreciation after 1 year would be 5% of 90,000, which is 4,500. So the value of the home after 1 year would be 90,000 plus 4,500, which would give us 94,500. To calculate the increase in value after 2 years, it would be 5% of 94,500, which was the value of the home after 1 year, and this would give us $4,725. So the value of the home after 2 years would be $94,500 plus $4,725, which would give us $99,225. Let's move on to currency conversion. In these questions, you will be provided with currency exchange rates and asked to calculate how much of one kind of money is equivalent to another. In this example, 2 exchange rates were given. 1 US dollar is equivalent or equal to $6.45 TT, and 1 Bayesian dollar is equal to $3 TT. Using the rates, calculate how much Bayesian dollars is equivalent to 1 US dollar. If 3 TT dollars is equal to 1 Bayesian dollar, 1 TT would be 1 over 3. So $6.45 TT, which according to the rate is equivalent to 1 US dollar, is equal to 1/3 multiplied by $6.45, which would give us $2.15. Hence, 1 US dollar is equal to $2.15 Bayesian money. Part B. John exchanged 1,500 Bayesian dollars for US dollars. Calculate how much US dollars he received. So in Part A, we calculated that $2.15 Bayesian is equal to 1 US dollar. Therefore, 1,500 Bayesian dollars would be 1,500 divided by $2.15, which is equal to $697.67 US. The next topic is rates. Like ratios, rates involve a comparison of quantities. A unit rate is the rate per 1 unit. For example, the speed of a vehicle is 80 km per hour, which gives the distance traveled in 1 unit of time, which is 1 hour. When solving problems with rates, different methods can be used. In example 1, a car consumes 20 liters in traveling a distance of 400 kilometers. Calculate the distance covered in consuming 14 liters of fuel. So we know that the distance covered with 20 liters is equal to 400 kilometers. Therefore, the distance covered with 1 liter would be 400 divided by 20, which is equal to 20 kilometers. So with 14 liters, the distance would be 20 times 14, which is equal to 280 kilometers. Number 2. If 12 men complete a job in 5 days, how long will it take 15 men to complete the job given that they work at the same rate? So we know that 12 men take 5 days. Therefore, 1 man will take 12 times 5, which is equal to 60 days. So, 15 men will take 60 divided by 15, which is equal to 4 days. In number 3, 2 quantities are in the ratio 8:7. If the smaller quantity is 35, what is the larger quantity? So 7, being the smaller quantity, represents 35. Therefore, 1 part will represent 5. So 8 parts will represent 8 times 5, which is equal to 40. Another way this can be worked is by letting the larger quantity be a variable, so let's say y. So 8 over 7 would be equal to y over 35, and by cross multiplying we will get 7y is equal to 280. Therefore y would be 280 divided by 7, which would give us the same answer as 40. Now we're going to look at solving word problems involving utility bills. In number 1, a company charges the following monthly rates for all local telephone calls. Part A, calculate the total bill for each of the following customers. Part 1, George, who made 12 local calls for the month. Part 2, Sarah, who made 52 local calls for the month. And Part 3, Paul was charged a total of $65.25 for local calls in a certain month. How many calls did he make for the month? So the total bill for George would be 12 by $1.75 since he made less than 15 calls, which is equal to $21. In part 2, Sarah, who made 52 calls, so her first 15 calls would be $1.75 times 15, which is equal to $26.25, and her remaining calls would be 52 minus 15, which is equal to 37, so that would be 37 by 75 cents, which is equal to $27.75. Therefore, her total bill would be the sum of the two, which is equal to $54. In part 3, we were given the total bill, and we already know that the first 15 calls cost $26.25, so the cost of the remaining calls would be $65.25 minus $26.25, which would give us $39. So the number of remaining calls would be $39 divided by 75 cents, which is equal to 52 calls. Hence, the total number of calls would be equal to 67 calls. Number 2. The table above shows John's electricity bill for a period of 1 month. Calculate part 1, the number of units in kilowatt hours, that is, the unit of energy used for the month, and part 2, John's bill inclusive of VAT for the month. So part 1, the number of units used, would be the present reading minus the previous reading, which is equal to 1092 kilowatt hours. In part 2, the total bill would be fuel charge plus energy charge plus VAT. So the fuel charge would be $1,911, the energy charge $1,365, and VAT would be 15% of the sum of the two, so $491.40. Hence the total bill would be $3,767.40. So this brings us to our last topic, salaries and wages. When employees work beyond their normal schedule of hours, they are paid extra money for doing so, and this is referred to as an overtime wage. The normal wages earned without overtime is called the basic rate of pay. Now, overtime rates vary. It can be 1.5 times the basic rate, which is referred to as time and a half, or 2 times the basic rate, which is referred to as double time. Let's look at this example. A company pays a basic wage of $900 for a 40-hour week. Overtime is paid at time and a half. Part A, calculate Part 1, the basic hourly rate, and Part 2, the overtime rate. Part B, an employee worked 20 hours overtime in a certain week. Calculate Part 1, the employee's overtime earnings for the week, and Part 2, the employee's total earnings for the week. Finally, Part C, another employee earned $1,305 in a particular week. How many hours of overtime did she work? In Part A, the basic hourly rate would be $900 divided by 40, since it is a 40-hour week, which is equal to $22.50. In Part 2, the overtime hourly rate would be $22.50 times 1.5, since it's time and a half, which is equal to $33.75. In Part B, the overtime earnings would be $33.75 times 20, since it's 20 overtime hours, which is equal to $675. Therefore, the total earnings would be the basic wage plus the overtime wage, which is equal to $1,575. In Part C, before we can find the number of overtime hours, we need to find the overtime wage. So 1,305 minus the basic wage of $900 would be $405. So the number of hours overtime would be 405 divided by $33.75, and this would give us 12 hours. Number 2. Susan works a basic 36-hour week at a rate of $14.80 per hour. She is paid double time for every hour worked over 36 hours. Calculate her total pay if she works 42 hours in a week. So we know her total pay would be basic wage plus overtime wage. Her basic wage would be 36 times $14.80, which is equal to $532.80. Her overtime rate would be $14.80 multiplied by 2 since it's double time. Therefore, her overtime wage would be $29.60 multiplied by 6, which is equal to $177.60. And we know it's 6 hours because it's a 36-hour week, so 42 minus 36 is 6. Hence her total wage would be $710.40. And we have reached the end of consumer arithmetic. I hope these videos were helpful. Please continue to practice questions. Good luck, everyone!